Welcome to Section 9, Lesson 5. Solving a rational equation means finding x values that make the equation true. The procedure starts by clearing fractions, but the end of every problem must include a check, because clearing fractions can introduce solutions that do not actually solve the original equation. The procedure has 3 steps. First, find the LCD of every fraction in the equation, exactly the same LCD you would compute for adding rational expressions. Second, multiply both sides of the equation by that LCD, which clears all the fractions. Third, solve the resulting polynomial equation using the techniques from sections 8 and 9. The fourth and crucial step is to check each candidate in the original equation. Multiplying by an LCD is allowed only when the LCD is non-zero. If a candidate solution makes the LCD equal to 0, that candidate is extraneous. It solves the cleared equation, but not the original. Today's 2 examples show the contrast. The first produces a candidate that turns out to be extraneous, leaving the equation with no solution. The second produces 2 valid candidates that both check out. Take 1 over x plus 1 over x plus 1 equals 3 halves. 3 small fractions in the equation, 2 of them with variable denominators, 1 numerical. Find the LCD. The denominators are x plus 1 and 2. Their LCD is 2x times x plus 1. Multiply both sides of the equation by this LCD to clear every fraction. Multiplying through gives 2 times x plus 1 plus 2x equals 3x times x plus 1. Expand both sides. 4x plus 2 equals 3x squared plus 3x. Move everything to one side. 3x squared minus x minus 2 equals 0. Factor or use the quadratic formula. The solutions are x equals 1 and x equals negative 2/3. Check both in the original. Neither makes the LCD 0, so both are valid. Solve x over x minus 2 equals 2 over x minus 2 plus 3. The same denominator x minus 2 appears on both sides, so the LCD is just x minus 2. Multiply both sides by x minus 2. The equation becomes x equals 2 plus 3 times x minus 2. Expand and solve the x equals 2 plus 3x minus 6, which gives negative 2x equals negative 4, so x equals 2. Now check x equals 2 in the original. The denominators on both sides are x minus 2, which equals 0 when x equals 2. The original equation is undefined at x equals 2, so the candidate is extraneous. Conclusion: the equation has no solution. The clearing step gave us a valid algebraic candidate, but the candidate fails the domain check. This is exactly why every rational equation requires the final check. Without it, we would falsely report x equals 2 as the answer. Example 2. Solve 6 over x plus 6 over x plus 2 equals 5. 2 fractions on the left, a constant on the right. The LCD is x times x plus 2. Multiply both sides by the LCD. The left becomes 6 times x plus 2 plus 6x. The right becomes 5x times x plus 2. Expand 12 plus 6x plus 6x equals 5x squared plus 10x. That simplifies to 5x squared minus 2x minus 12 equals 0. Factor or use the quadratic formula. The solutions are x equals 2 and x equals negative 6/5. Check both in the original. X equals 2, the denominators are 2 and 4, neither 0, so the equation is defined. X equals negative 6/5, the denominators are negative 6/5 and 4/5, neither 0. Both candidates check out, so both are valid solutions to the equation. 3 takeaways for solving rational equations. The third one is the most important. Find the LCD of every fraction in the equation, then multiply both sides by it. This clears every denominator and turns the rational equation into a polynomial equation. The LCD finding skill is identical to Lesson 3's addition procedure. Solve the polynomial equation that results. If it is linear, isolate x. If it is quadratic, factor or use the quadratic formula. If it is cubic or higher, factor by techniques from Section 8. The polynomial solving skill is what Sections 7 and 8 prepared you for. Always check candidates in the original equation. A candidate that makes any denominator 0 in the original is extraneous and must be rejected. Skipping the check is the most common error in this lesson, and it produces wrong answers that look right at first glance.